Welcome to the weirdest corner of physics, quantum mechanics. Prepare to question everything you know about reality. For centuries, we thought the universe was predictable, following simple, classical laws. But over 100 years ago, scientists encountered something truly bizarre when studying the smallest things, particles. Today, we dive into the most famous experiment proving reality is strange, the Double-Slit Experiment. The setup is simple. A source fires something, which passes through a barrier with two vertical slits, and then hits a detection screen. First, let's look at how waves behave. Imagine tossing pebbles into water with a barrier. When the waves overlap, they interfere, creating a pattern of alternating high and low-intensity bands on the screen. This is called an interference pattern, the signature of a wave. Now, let's consider classical particles, like tiny bullets. If we fire them at the slits, we expect them to pass through one slit or the other, creating two distinct vertical bands on the screen. This pattern, two lines, is the signature of a particle. Simple enough, right? Now enter quantum mechanics. Instead of bullets, we fire electrons, fundamental particles of matter. When we fire millions of electrons and check the screen, what do we see? Astonishingly, the electrons create an interference pattern, just like waves. This means each electron somehow behaved like a wave, passing through both slits simultaneously. But wait, electrons are indivisible particles. How can one particle be in two places at once? Skeptics suggested the electrons must be bumping into each other, creating the wave effect. So, scientists decided to fire the electrons one at a time, sometimes hours apart. After thousands of individual electrons hit the screen, the results were undeniable. The interference pattern reappeared. Each individual electron interacted with itself, traveling both paths simultaneously. This is superposition. The particle exists in all possible states, passing through both slits, until it is forced to choose. Now for the biggest twist. What if we simply observe which slit the electron goes through? The moment we introduce an observer, the reality changes. The interference pattern vanishes instantly. The active measurement forces the electron to collapse its wave function and choose a single reality. It becomes a definite particle, traveling through one slit only. The double-slit experiment proves that reality is fundamentally different at the quantum level. Observation doesn't just record reality, it creates it.